Good morning! Today, we will learn about quadratic inequalities. So what is a quadratic inequality? A quadratic inequality is an inequality that contains a polynomial of degree 2 and can be written in any of the following forms. Ax squared plus bx plus c is greater than 0. Ax squared plus bx plus c is less than 0. Ax squared plus bx plus c is greater than or equal to 0, and ax squared plus bx plus c is less than or equal to 0, where a, b, and c are real numbers and a is not equal to 0. Here are some examples of quadratic inequalities. 2x squared plus 5x plus 1 is greater than 0. S squared minus 9 is less than 2s. 3r squared plus r minus 5 is greater than or equal to 0. T squared plus 4t is less than or equal to 10. So how do we solve quadratic inequalities? To solve a quadratic inequality, follow these steps. Step 1. Change the quadratic inequality to a quadratic equation in standard form. Step 2. Solve the quadratic equation using any of the following methods: extracting square roots, factoring, completing the square, or using the quadratic formula. Step 3. Graph by plotting the roots on the number line. Open circles are used if the roots are not part of the solution set or if the inequality symbol used is greater than or less than. Solid circles are used in the graph if the roots are part of the solution set or if the inequality symbol used is greater than or equal or less than or equal. Now darken the part or parts of the number line that represent or represents the solution set. And then for the last step, write the solution set of the inequality. You may look at the corresponding graph of each inequality in the given figure. Let's now have some examples. For our first example, we have find the solution set of x squared plus 7x plus 12 is greater than 0. For step 1, change the quadratic inequality to a quadratic equation in standard form. So if we are going to change this to a quadratic equation in standard form, we have x squared plus 7x plus 12 is equal to 0. Step 2, solve the quadratic equation using any method. So let's say we use factoring to solve the given quadratic equation. What are the factors of 12 that will give us 7 when added or subtracted? That would be positive 4 and positive 3, because 4 times 3 is equal to 12 and 4 plus 3 is equal to 7. Applying zero product property, we have x plus 4 is equal to 0 and x plus 3 is equal to 0. Solving for x, we have negative 4 and negative 3. Next, graph by plotting the roots on the number line. Open circles are used if the roots are not part of the solution set or if the inequality symbol used is greater than or less than. Solid circles are used in the graph if the roots are part of the solution set or if the inequality symbol used is greater than or equal to or less than or equal to. Okay, so let us plot the roots on the number line. The roots are negative 4 and negative 3. Since the inequality symbol used is greater than, we will use open circles. Now we will darken the parts of the number line that represent the solution set. So we may simply refer to the given figure on the upper right corner of our slide. So the corresponding graph of the given inequality is the first one. Therefore, this is the graph of our quadratic inequality. The solution set, for step 4, we are asked to write the solution set of the given inequality. So we say that the solution set is the set of all x's such that x is less than -4 or x is greater than -3. Let's have another example. Find the solution set of x squared minus x minus 12 is greater than or equal to 0. So for our first step, change the quadratic inequality to a quadratic equation in standard form. So we have x squared minus x minus 12 is equal to 0. Next, solve the quadratic equation using any method. So let's use factoring to solve the given quadratic equation. Now, what are the factors of -12? That will give us -1. When added or subtracted, that would be -4 and +3. Applying zero product property, we have x minus 4 is equal to 0 and x plus 3 is equal to 0. Solve for x sub 1 is equal to 4, x sub 2 is equal to -3. For step 3, graph by plotting the roots on the number line. So we will plot +4 and -3 on the number line. We have +4 and then -3. Since the inequality symbol used is greater than or equal to, therefore we will use solid circles, which means that -3 and +4 are part of the solution set. So referring to the corresponding graph of the inequality, our graph will look like this. Write the solution set of the inequality for step 4. Therefore, the solution set of the inequality is the set of all x's such that x is less than or equal to -3 or x is greater than or equal to +4. For our third example, we have find the solution set of 2x squared minus 5x is less than 3. So for step 1, change the quadratic inequality to a quadratic equation in standard form. We have 2x squared minus 5x is equal to 3. Next, move all terms to the left side of the equation, so it becomes 2x squared minus 5x minus 3 is equal to 0. This is now our quadratic equation in standard form. For step 2, solve the quadratic equation using any method. Let's say we use quadratic formula. The quadratic formula is given by negative b plus minus the square root of b squared minus 4ac all over 2a. Let us first identify the values of a, b, and c. So in the given equation, a is 2, b is negative 5, and c is negative 3. Let us substitute these values in the quadratic formula. So we have negative 5 plus minus the square root of negative 5 squared minus 4 times the value of a, which is 2, times the value of c, which is negative 3, all over 2 times a, which is 2. Let us simplify. Negative of negative 5 is 5, plus minus the square root of negative 5 squared is 25. Negative 4 times 2 is negative 8 times negative 3. We have positive 24. All over 2 times 2, 4. 5 plus minus the square root of 25 plus 24 is 49 all over 4. And this is 5 plus minus the square root of 49 is 7 all over 4. For our x sub 1, we have 5 plus 7 all over 4. And then for our x sub 2, we have 5 minus 7 all over 4. This is now equal to 12 over 4. And that is equal to 3. For our x sub 2, we have negative 2 all over 4. In simplest form, that will be negative 1/2. Therefore, the roots of the quadratic equation are 3 and negative 1/2. For step 3, we will graph by plotting the roots on the number line. So we will plot positive 3 and negative 1/2 on the number line. Since the inequality used is less than, therefore we will use open circles. We have here positive 3, and then negative 1/2 is located between 0 and negative 1. Now we will refer to the graph of the inequality. So our graph will look like this. Therefore, the solutions of the given inequality are between negative 1/2 and positive 3. Step 4, write the solution set of the inequality. So the solution set will be the set of all x's such that x is greater than negative 1/2 but less than positive 3. Let's have our next example. Find the solution set of x squared plus x minus 6 is less than or equal to 0. For our step 1, change the quadratic inequality to a quadratic equation in standard form. So it becomes x squared plus x minus 6 is equal to 0. Step 2, solve the quadratic equation using any method. Let's use factoring. What are the factors of negative 6 that will give us positive 1 when added or subtracted? That would be positive 3 and negative 2. Positive 3 times negative 2 is negative 6. Positive 3 plus negative 2 is positive 1. Let's apply zero product property. X plus 3 is equal to 0. X minus 2 is equal to 0. Solve for x. X sub 1 is negative 3. x sub 2 is positive 2. For the next step, we graph by plotting the roots on the number line. So the roots are negative 3 and positive 2. Since the inequality used is less than or equal to, we will use solid circles, which means that negative 3 and positive 2 are part of the solution set, referring to the corresponding graph of the given inequality. So we have this graph. Therefore, the solution set of the given inequality are from negative 3 to positive 2. So how do we write our solution set? The solution set of the inequality is the set of all x's such that x is greater than or equal to negative 3 but less than or equal to positive 2. So that is how we solve quadratic inequalities in one variable. Thank you very much.